Yeah, good afternoon, friends. I, Dr. Devesh Bandel, Associate Professor, Suresh Gyan Vihar University, accredited by NAC A grade. Today, I will discuss about implementation of merge sort. You know, merge sort is a technique of your sorting. There are so many techniques of sorting, like your insertion sort, bubble sort, radix sort, quick sort. Okay, and merge sort is one of the most sorting algorithm, and through this algorithm you can also sort the item which are already inserted in your array. Before starting the merge sort algorithm, I will discuss about the sorting. What is sorting? Sorting means where all item which who are inserted in your array, if your items all items are in your sorting fashion, so that is your sorting. And if your items are not in your sorted fashion, so through this technique, like your merge sort, you can arrange the all items in your sorted fashion. Okay, you know merge sort is the technique of your sorting, and sorting is the one of the most important topic of your data structure and algorithm. The objective of your data structure and algorithm to emphasize the concept of your algorithm: stack, linked list, tree, searching, and your sorting. And if we will talk about the outcome of this paper, so after studying this paper, student will able to write the concept of your algorithm, write the concept of your stack, linked list, tree, searching algorithms. And now here I am discussing about the implementation of your merge sort algorithm. I am sharing my screen. You know, you can see my screen. I hope you can see my screen. Duration this lecture, I will discuss about merge sort in data structure, and also I will discuss about example of your merge sort. Also, I will discuss about algorithm of your merge sort, implementation of your merge sort, advantage and disadvantage of your merge sort. First of all, I am I will discuss about what is merge sort. Merge sort is the one of the sorting algorithm from quicksort, insert sort, bubble sort, radix sort, insertion sort, etc. And your merge sort is based on your divide and conquer technique. This is the main key concept of your merge sort algorithm. Your merge sort algorithm is based on your divide and conquer method. Divide and conquer method, like suppose you have a big task. Suppose you have a big problem and you want to solve this big problem. Okay. If your big task is divided into many subtasks, the completion of your subtask is simple compared than completion of your full task. So divide means first of all your big task is divided into many subtasks and your many tasks, many subtasks will execute independently. And after execution of subtask, your subtask will combine. So that is your divide and conquer technique. Like about the software, when you are making a software, in your software you have a team. There are so many employees are working on your software, and each worker have an independent task. Like your one employee task is your write the code, one employee task is to analyze the data, one employee task is differ, one employee task is differ. So first of all, your software will divide it into your subtask. Your big task is divided into your subtask, and your subtask is divided to individual person. Okay. And your individual person will complete the our task, will complete the subtask, and after completion of your subtask, your all subtask will be combined. Okay. Like your module, about a module like your particular task. So if you want to complete the module, so first of all your module will divided into your module will divided into your sub module, and your sub module will divided to the independently person. Okay. And your each employee will perform the our sub module, and after completion of sub module, your sub module will be combined. Okay. So your merge sort algorithm is based on your divide and conquer method, as per I had given example. And merge sort first divide the array into your equal halves. When you will apply the technique of your merge sort, first of all your merge sort divided the array into your equal halves. After then combine then a sorted manner. So means in your merge sort, you will focus only two tasks. First is your merge sort is a sorting technique based on your divide and conquer method, and in your second task, your merge sort first divided the array into your equal halves. Here I am talking about the array. About the array. array is your collection of your similar data items. So in your merge sort, first of all, you will take the array. Suppose your array size is your 10. So first of all, your array size will divide it into your halves. Okay. And after divided the halves, and then combine them into a sorted manner. So this is your merge sort. Here, I am taking the example of your merge sort because the main objective of this lecture is to implementation of your merge sort. If you know about the merge sort, if you know about the concept of your merge sort, so you can implementation this algorithm in a sort in a simple manner. And if you don't know about the what is merge sort and how to write the example of your merge sort, so as per my opinion, when you will implementation the merge sort algorithm in any other programming language, definitely you will face the problem because you don't know any concept about your merge sort. You don't know about any statement, about any instructions of your merge sort. And if you know about the example of your merge sort, if you know about the algorithm of your merge sort, so definitely when you will write the program of your merge sort, you will not face any problem. That's why first of all I will discuss about the example of your merge sort. In your merge sort, first of all, I will take a unsorted array because if you will take the sorted array, so in your sorted array, your all items are already in your sorted fashion. So that time your sorting is not required, and your sorting is required only in which case where your all items are not in your sorted fashion. Okay. So first of all, I will take a array of your unsorted items like your 14, 33, 27, 10, 35, 19, 42, and your 44. Means in this array, I will take the 8 items. Okay. And you can see in this given slide, you can see in this given slide, I have to take an array of your 8 size. So as per the definition of your merge sort, as per the steps of your merge sort, first of all, you will first divide the whole array. Okay, whole array means in which I have taken 8 items. So first of all, your whole array will divide, okay, into your equal halves unless the atomic value are achieved. Okay. So first of all, you will, as per the given instructions in this slide, first of all, you will divide the array in your equal halves. Means when you will divide this array in your equal halves, so your first half of 4 items and second half of your 4 items. Okay. Your first half will be your left sub first half will be 14, 33, 27, and your 10. This is your first half when you have to divided the array in your equal halves, and your right hand half is your 35, 19, 42, and your 44. Okay. So you can see in this given slide, your first half will contain the 4 item and your second half will contain the 4 item. Okay. After that, we divide these two array into your halves. Okay. Here I had already told about that whole array iteratively into equal halves unless the atomic value are achieved, unless the 1 1 value are achieved. Okay. So first of all, you have to divide the array into your equal halves, and after that, again, we divide the two array into your equal halves. Okay. In your first sub half contain the four item. These are 14, 33, 27, and your 10, and your equal half, and your second half is that 35, 19, 42, and your 44. And after that, we divide these two array into your halves. Your first half will be 14, 13, 33. Second half will be 27, 10. Basically, these two halves are created from your first half, who is that 14, 33, 27, and your 10, and your second half, that is your 35, 19, 42, and 44. When you will divide the right hand sub half, that time your half will be 35, 19, and your 42, and your 44. Okay. And after that, we further divided these array: 14, 33, 27, 10, 35, 19, 42, and 44. Okay. You can see in this given slide, I have mentioned the whole array iteratively into equal halves unless the atomic value are achieved. And here you can see you have to achieve the atomic value, like your 14, 33, 27, 10, 35, 19, 42, and your 44. Okay. And after that, as per the second step of your merge sort, we combine them in exactly the same manner as they were broken down. Okay. So we first compare the element for each list and then combine them into the another list in your sorted manner. We see that 14 and 33 are not in sorting fashion. You can see in this slide, your 14, first of all, you will compare 14 and 33. 14 and 33 are in your sorting fashion, so that time your swapping is no required. That time your swapping is no required because 14 and 33 are already in your sorting fashion. Okay. And after that, we will compare the 27 and 10. You can see here, when you will compare the 27 from 10. Okay. So 27 is greater than from your 10. And as per the sorting fashion, 10 will come first before the 27. So that time your swapping is required. Swapping is required means after the swapping, your after the swap, your 10 will take the place of your 27, and your 27 will take place of your 10. And here your swapping is required. About the concept of your swapping. When you want to apply the swapping, your swapping will apply from your two methods. In your first method, you can take the third variable for swapping, and you can take the another method without your third variable. If you will take the third variable, suppose your third variable is your C, and your first variable is your A, and second variable is your B, and you want to swap the value of your both two variable A and B. So you will write the concept for swapping C assignment operator A, and when this statement will execute, so the value of A will assign into your third variable, And when you will write the second step, a assignment operator b means the value of v assigned into your a variable. And in your third step, when you will write the third step, b assignment operator c means the value of your third variable will assign into your b. And after executed these three statements, your a variable will take the value of v variable, and your v variable will take the value of a. Means after swapping, your 10 will take the value of 27, and your 27 will take the value of 10. Okay. So we compare 27 and 10, and the largest list of two value are, we put 10 first. Obviously, when you will combine these, first of all 14, 33, 27, and your 10. Okay, first of all you have to combine the atomic value like your 14 and 33. After that you will combine, you know, when you have to combine the 14 and 33, 14 and 33 are already in your sorted fashion. And when you will combine the 27 and 10, and your 27 and 10, these are not in your sorted fashion, that time your swapping is required. Means after swapping, your 10 will be placed on your position of your 27, and your 27 will put on the position of your 10. Okay, and after that you will combine. So 10 will take the first value. After that, your second value, your 27 will take the second. 33, 14. Sorry, first of your 10, second is your 14, third is your 27, and fourth is your 33. And in the same manner, when you will combine the 35 and your 19, 19 is the less than from your 35. That time your swapping is required. And after swapped, your 19 will take the place of your 35th element position, and your 35th will take the position of your 19 value. Okay, and after that you will combine the 42 and 44. 42 and 44 are already in your sorted fashion. And after that you will combine the 35, 19, 42, and your 44. And that time, first of all, you will place the 19. After that you will place 35. After that you will place the 44, and after that you will place the 44. Okay, you can see in this given slide. First of all, you will combine the 40 and 33. After that you have to combine 10, 27, 19, 35, and 42 and 44. And you can see in this given slide, in your first line, all elements are in your sorted. And in your next iteration of the combining phase, your 10 is the minimum value, so 10 will take the first. After that you will take the 14. After that you will take the 27. After that you will take the 33. Okay, and in your right hand side you will take the 19. After that 35. After that 42, and after that the 44. Okay, here you can see, after the merging, your new array will be 10, 14, 19, 27, 33, 35, 42, and 44. In this array, you can see your all item are in your sorted fashion, because 10 is less than from your 14, 14 is less than from your 19, 19 is less than from your 27, 27 is less than from your 33, 33 is less than from your 35, 35 is less than from your 42, and 42 is less than from your 44. and now your list is sorted. Okay, and after applying the sorry before applying the merge sort technique, your array was not in your sorted fashion, and after applied the merge sort algorithm, your new array will be in your sorted fashion. And now I will discuss about the algorithm of your merge sort, because I had already told before the implementation of any technique, if you will write the algorithm of particular technique, after write the algorithm, if you will make the program, if you will write the program for the particular technique, you will not face the problem, because in your algorithm, which instructions, what are the instructions you will apply in your program, these are totally absolute clear in your mind. You first of all, you will write this instruction, after that you will write this instruction, after that you will write this instruction. That's why your algorithm is compulsory before implementation of any technique. Algorithm, I think all are known about the algorithm. Algorithm is the step by step instructions for achieve the target, for achieve the goal. There is no any foundation. You first of all, you will write this instruction, after that you will write the instruction, after that you will write the instruction. There is no any foundation. Only when you want to write the algorithm, only you will just write the statement, you will just write the instructions step by step for obtaining the output, for obtaining the desired output. And here I am discussing about the algorithm of your merge sort. In your step first, if it is only one statement in this list, if it is already sorted and your return. Obviously, if your list is already sorted, so you will return. And in your step 2, divide the list recursively into two halves. I had already told in starting this lecture, in the merge sort algorithm, your merge sort algorithm is based on your divide and conquer method. So first of all, you will divide the list recursively into two halves. Here, I had used the new word recursively. Means you will divide the list again to again until you will find the atomic value. Okay, that's why I had told about the divide in this algorithm. Divide the list recursively into two halves until it can no more be divided, until you can got the atomic value. Okay, and in your third step, merge the smaller list into a new list in your sorted manner. Means first of all, you will divide the list in your divide and divide method, and after that you will merge the smaller list into new list into your sorted manner. Okay, this is your algorithm of your merge sort. And step is optional in your algorithm. If you don't want to write the step number, no problem. And if you want to write the step, there is no problem. Means there is no any restrictions key your you will write the step number. There is no any foundation. That is, this is depend only you. If you want to write the step number, you can write, and if you don't want the write the step number, that is not a problem. And after that, implementation of this algorithm. You know, this algorithm is based on your divide and conquer. Divide and merge means first of all you will divide and after that you will merge. So first of all you will make a function for the divide and after that you will make a function for merge. Okay, and your merge sort work with recursion. Recursion means many times itself. Okay, so merge sort works with your recursion. Recursion, suppose I am talking about the recursive function. So recursive function means if your function will call the itself is called the recursion function. And here, first of all, I have make a procedure for the merge sort. Okay, and you will take the first array and you will take the second array. You know your array will divide it into your equal halves, and after that you will apply the merge sort. First of all, you will apply the merge sort in your first, and after that you will apply the merge sort in your second. Okay, and you will return the merge. Okay, and your procedure have to be finished. And first of all, you will make a procedure for the merge. In your merge, you will take the variable as your array, and you will write the condition a and b have elements. If your first element greater than from your second, you will add to the end of c, and you will remove your zeroth index. Else, add your first index variable, and after that, okay, you will remove the zero location from a and if your while is your end. And in this, while a is at elements, first of all you will add the zero location at end of c, and you will remove from the zero location, and your while will be end. If your b is the element, first of all you. And now I will talk about the advantage of your merge sort. Means if you want to use the merge sort technique for sorted the elements which are not in your sorting fashion, so what are the advantages if you want to use the merge sort? Advantage of your merge sort, it can be applied to files of any size. First of all, your first main advantage is that you will apply to files of your any size. And if we will talk about the insertion sort, if we will talk about the selection sort, so your insertion sort and selection sort will apply to the small size file. Means in your insertion sort, in your selection sort, you will take the array of small size. And if we will talk about, if I will talk about the merge sort, so it can be applied to file of any size. And second is that reading of one input during the run creation step is sequential, not much seeking. Okay. And your third step, if heap sort is used for in the memory part of the merge, its operation can be overlooked with input output. These are the all advantage of your merge sort. Main advantage of your merge sort algorithm is that your this technique will apply to file of any size. And if we will talk about the disadvantage of this algorithm, the first disadvantage is your re- require the extra space. If you want to apply the merge sort algorithm, so you require the extra space. And second is that merge sort require more space than the other sort. Okay. If you will use the selection sort, if you will to use the insertion sort, so your selection sort and your insertion sort require the little space. And if you will use the merge sort, so merge sort require the large space compared than your other sorting algorithm, and your merge sort is less efficient than the other sorting algorithm. This is the disadvantage of your merge sort algorithm. And if we will talk about the difference between merge sort and your insertion sort, so here you can differentiate between merge sort and your insertion sort in many domain, like your time complexity. In merge sort, the worst case is n log n, and your average case is n log n, best case is n log n, whereas the insertion sort and the worst case is your n square, average case is your n square. This is the difference between merge sort and insertion sort. uh, Time complexity domain. And if your space complexity, merge sort being recursive takes up the space complexity is n, hence it cannot be preferred over the place where memory is a problem. And data set, merge sort definitely preferred for her data set, and your other algorithm preferably define the minimum size data set. Efficiency, considering the average time complexity of both algorithms, we can safely say to the merge sort is efficient in terms of time, and insertion sort is efficient in terms of your space. And your sorting method, merge sort is an external sorting method in which the data that is to be sorted cannot be accommodated in memory and need auxiliary memory for sorting, whereas insertion sort is based on the idea that one element from the input element is consumed in each iteration to find its correct position. And stability, merge sort is stable as two elements with equal value appear in the same order in the sorted output. And now here I am giving the some questions which are related from this lecture. Merge sort use which of the following technique is implement sorting? So I had already discussed about the divide and conquer method. When I have to start this lecture, divide and conquer, I had already explained about your divide and conquer method. So your merge sort is based on your divide and conquer method. And what is the average case time complexity of your merge sort? N log n square log n, and your n log n square. Okay. So the recursion relation for merge sort is given by 2t n by 2 plus n. It is found to be equal that n log n using the master theorem. And what is the auxiliary space complexity of your merge sort? Okay, so your first log n, and your n log n. You know your n is the auxiliary space complexity of your merge sort, and merge sort can be implemented using auxiliary space true and false. So your answer is absolutely true, because standard merge sort required the n space to merge two sorted array. And what is the worst case time complexity of merge sort? N log n square log n, and your n log n square. The time complexity of your merge sort is not affected by the worst case, as its algorithm has to implement the same number of steps in any case. And after studied this lecture, student will able to give the answer of following question, like your what is your merge sort. I had already explained about the merge sort in starting of this lecture. And what is the sorting? you know if we will talk about the sorting, I had already explained sorting, where your all items in your array is in your sorted fashion. This is your sorting. And comparison between merge sort and selection sort, I had already explained about the merge sort and selection sort in your many domain. And what is the algorithm of your merge sort, I had already explained duration this lecture about the algorithm of your merge sort, and what are the advantage of your merge sort. And also I had already explained the advantage of your merge sort algorithm. I hope you have to understood about the implementation of your merge sort. And after studying this lecture, student will able to give the answer for what is sorting, what is the merge sort technique, what is the divide and conquer technique, what are the advantage of your merge sort, what is the advantage of your merge sort. you know these are the many sorting technique as per I had told: insertion sort, selection sort, merge sort, bubble sort, radix sort, and your quick sort. And each technique have its own advantage and its own disadvantage. Like your selection sort and your insertion sort is applicable for small size of your array. Means if you are taking the array of your limited items, your selection sort and your insertion sort will give the rich performance. And if you will take the merge sort, so your merge sort is applicable for large size of your items array. I hope you have to understood about the merge sort.